You are welcome for the fourth episode of physics. Now we are going to discuss about the refraction of light. We know light travels along straight line. Light travels along straight line, such as light from a torchlight we can see going through a straight line. Now, if light when travels from one transparent medium to another, that means from first medium to second. Now also that one travels in the straight line. Now also it travels in the straight line or not. See, in the first medium, light travels along straight line. When we consider second medium along, then also light travels along straight line. But from one medium to another, when it travels from one medium to another, it travels along straight line. See, in the case of a pencil kept in a water, that means the water is taken in a glass and a pencil is kept in this water, you can see there is a deviation of the pencil in the water. Why this deviation? That means when we observe this pencil from other side, we can see light from water coming from different directions. That means light appears to coming from different directions when comparing with the pencil outside the water. That means here pencil is in two media. One is it in air and second in water. When we observe this, we can see light appears to coming from different directions as that of comparing with a pencil in air. This is the reason for the deviation. This is the deviation. That means what is the reason for deviation, sir? That means a pencil in the water, from there light appears to coming from different directions, but from air it is not like that. That is the reason for the deviation or the reason for refraction. What is the reason for refraction here or deviation of the pencil? It is light from water appears to coming from different directions. Now you see another one example. This is a lemon. See, its size is smaller. But when we place this lemon in water, you see its size increases. See, now the size of the lemon is large. Why? This is also due to refraction. This is also due to refraction. Now we see one more example. That means if I am held this glass, this arrow mark is going from, that is left to right. This arrow mark is going from left to right. If I place this glass here with the water, you see the arrow mark here, you can see appears from right to left. See, here arrow mark is going from left to right, but now it is viewed through water, you can see it is from, that means right to left. It is this also due to refraction. This also due to refraction of light. See here why this happens. Now if one more example, see, this is a straight line drawn in a paper. Now if I place a thick glass block, that means glass slab, over this, making an angle. See, here it makes an angle. Now, see, here, this line makes an angle with this one. This line makes an angle with this one. So, here also you can see deviation for this line. But if this line is normal to the surface, can you see? See, here it is normal. That means here it makes a zero angle. Now, you cannot observe any deviation, because here you see light appears to coming from same direction, not from all directions. Because of that, you can see light as the straight line as in the paper. Now, these are examples for refractions, and some other examples. Suppose if I am keeping, this is a coin. See, a coin is placed in this. You cannot see this coin now, but when I pour water to this, see, here when I place this coin, you cannot see this one. But if I pour water to this one, see, now you can see this coin. If there is no water, then you cannot see this coin. But due to this water, when we pour this, due to refraction, this coin is lifted slightly upwards. Because of that, we can see this coin even though it is not seen without water in this utensil. Now, see, if one more examples for refraction. Suppose if I place this glass slab over these writings, then when you place this one in this way, you can see this letters appears to be raised. That means the letter in this prism, in the glass slab appears to be raised. These are all due to refraction. So, actually what is refraction? Refraction is the bending or deviation. Refraction is the bending or deviation when light passes from one transparent medium to another transparent medium at the interface. See, here we can consider two medium. This one is air. Suppose this one is a glass slab. Here two mediums are, one air and the second one is a glass slab. Suppose here a ray of light from a laser torch. This incident obliquely. Obliquely means making some angle with this side. Suppose this glass prism we mark as A, B, C, D. Now to this side AB, a ray incident at an angle. This is the normal at the point of incidence. This is the angle of incidence. And this normal, when we extend it inside, this bend here. That means this light ray want to travel in this way, but it bend in this manner. This is the angle of refraction. This is the angle of incidence. And this is the angle of refraction. Here this is the point of, that means this is the point of interface. That means the point where the two surface joining. The point where the two mediums joining. here the ray bends. That means bending or deviating or changing direction of light ray when it passes from one transparent medium to another one. When it travels from one transparent medium, this air is a transparent medium and glass is another transparent medium. When light rays passes obliquely from one transparent to another, it bend or deviate or change direction. Which are the things may happen? Bending or deviating or changing direction at the interface, and this phenomenon is called a refraction of light, and that one is called a refraction of light. Now we want to discuss about a refraction through a glass slab. There are so many examples of refraction. Suppose when you look at a pond or a pool, if its depth appears shallow, or stick in water appears to bend, or fish in a water appears to raise up, or if you try to take a coin from a bucket completely filled with water from its side, you will find it difficult because due to refraction that coin appears little raised. When you try to take it, you may find it difficult. These are so many examples of refractions. Now we want to discuss about refraction through a glass slab. Refraction through a glass slab. See, what are the things going to or we are doing here? At first, take a drawing sheet like this. Take a drawing sheet like this. Now, take a drawing sheet like this. Now, see, place this glass prism or glass slab on it. That means here we place the glass slab on the drawing sheet where we fixed a paper, and on it we placed this glass slab. Then we mark the outer line of this glass slab. That in this drawing sheet we placed a glass slab and we marked its outside. That means with A, B, C, D is the sides marked on this glass slab. Then now taken out this glass slab, then we make a line which is oblique to the side like this, and then here fix it two pin. Here we fix it two pin. Then again place this glass slab over this marking. Then looking on the other side of the glass slab, again you fix two more pin. That now you can see here is glass slab, and here two pin we fixed there. Here one pin, here pin two. These two in a line. Now looking on the other side of this glass slab, fix third pin to this side. Now you can see 1, 2, 3. These three pins are in the same line. Now fix one more pin here. Now you can see these four pins in a line. These two and these two. When we looking through this, that is when we look here, we can see these four pins on the same line, just like this. See this. Now these four pins you can see on the same line. You can see these four pins now on the same line. See, this is the fourth pin. Now you are seeing on the same line. Okay. Now you can see these four pins are, that means 1, 2, 3, 4 pin on the same line. But when we take out this one, you see these four pins here. You can see these two pin, and that line is this one. Here these two pins, that is another line. But when we place this glass slab, you can see these four pins will be in the same line. Now after this, Take out this one and now draw one perpendicular here. Take out the glass slab and here also joining this, you draw one more perpendicular here. Now once again, what are the things we did? See, this is the glass slab. A, B, C, D. Now here we drawn on normal. This is the incident ray. E, yeah, incident ray. This is the angle of incidence. N, N dash, normal. Now looking here, two pin we fixed and looking through this. That means if you extend this line this way, it will go in this way. And when we draw this will come. And this M dash is the normal to the second face. And G, H is the emergent ray. Here I is the angle of incidence and R is the angle of refraction. For this is the angle and this. But you see, actually this incident ray should go through this way. But this one is now traveling like this. Now these two are parallel. These two, that means this incident ray and this emergent rays both are parallel. But the direction of this one is changing at the point where it enters from air to glass and also from glass to air. Whatever is the angle of incidence here, that must be here the angle of emergence. These two are equal. So from this you can find out refraction through a glass slab by using this activity. Now based on this refraction, there are two laws. There are two laws about refraction. One, this is the incident ray. Incident ray. This one is the refractor ray. This is the normal. These are the incident ray, refractor ray, normal. At the point of incidence, incident ray, normal. At the point of incidence of the two transparent media and refractor ray, they lie in the same plane. That means incident ray, refractor ray, normal, they are all lie in the same plane. The next one is this is the angle of incidence and its sign is sin I. This is the angular refraction and its angle is sin R. Then this ratio, that is sin I by sin R, it is equal to a constant and it is called refractive index. Sin A by sin R is equal to N. This N is a constant for a given color of light and a given pair of media. Sin A by sin R is equal to N and this N is called refractive index. And this law is called Snell's law and this one is called Snell's law. Which sin A by sin R is equal to N. What is N? N is the refractive index for a given color of light. If you use violet, then it is same for all. And if you use red, then it is slightly different one. So for a given color of light and for a given pair of media, sin A by sin R is equal to a constant, and what it is called refractive index. Which are the two refraction laws? One, incident ray, refracted ray, and normal. That are lie on the same plane. Then second one is what is sin A by sin R. Sin A by sin R is equal to n, and it is called refractive index. What it is called refractive index. And this law related to this one is called Snell's law. What it is called Snell's law, which is applicable for a given color of light and given pair of media. Given color of light and a given pair of media. Refractive index. See, refractive index or N. We know what is light travels from one transparent medium to another. It deviates. When light ray travels from one medium to another, it deviates or bends or changes direction. And this amount of deviation or bending, that depends on the refractive index of the medium. That means how much the amount of it deviates, that depends on refractive index. See, refractive index, why this happens means because light travels in different media with a different speed. For example, light travels through vacuum at a speed of 3 into 10 raised to 8 meter per second. In air, it is slightly less than this, that is 2.998 into 10 raised to 8 approximately. This one is. And for glass, it is 2 into 10 raised to 8 meter per second. And for water, it is 2.25 into 10 raised to 8 meter. This is for glass and this one is for water. See, speed of light is the same in all media. In vacuum it is with the maximum speed 3 into 10 raised to 8. That is approximately 3 lakhs kilometers in 1 second. Air slightly less. That we can take as approximately this one. And in glass it is 2 into 10 raised to 8. Water it is 2.25 into 10 raised to 8 meter per second. See, the difference you can observe in the speed of light when we consider different medium. So, refractive index depends on speed of light also. That means amount of deviation or change of direction depends on refractive index and it depends on speed of light. This is the medium, for example air first, and this is glass, for example medium 2. Here light travels with speed v1 and here let it be v2. Now refractive index of second medium with respect to first, refractive index we used to represent with n. Refractive index of second medium with respect to first is equal to, that is speed of light in first by speed of light in second. That means n21 means refractive index of second medium with respect to first one. That is equal to speed of light in first by speed of light in the second, or n21. Speed of light in first we take as v1 and second we took as v2. So n21 is equal to v1 by v2. Similarly, refractive index of first medium with respect to second. first medium with respect to second is equal to what will get V2 by V1. V2 by V1 is the refractive index of what is first medium with respect to second one. That is V2 by V1. If it is second medium with respect to first, what will get V1 by V2. If light travels from air or vacuum, suppose that we consider nearly equal speed. Suppose light travels from this vacuum is the first medium, then second medium is some other one. Then refractive index of that medium we can take, for example, refractive index of glass DNG. Refractive index of glass medium, glass is equal to, that is simply we can represent the speed of light in what is a vacuum by speed of light in glass. Then let it be V1 by V2. Here we simply say it as absolute refractive index. That is a refractive index of a medium with respect to refractive index of a medium with respect to vacuum is called what absolute refractive index. Absolute refractive index, and usually we represent with N. If it is for glass, then what is it? That is vacuum by glass. If it is water, that means vacuum by speed of light and vacuum by speed of light in water. If it is kerosene, then it's speed of light in what is vacuum divided by speed of light in kerosene. Some of the mediums refractive index here given. Just we can observe the refractive index of some of the mediums which are given in our table. See, the refractive index here given for air, it has 1 point refractive index of air, that is equal to how much? 1.003. And for ice, water, it is refractive index of water, it is how much? It is given as 1.33. And for alcohol, and next one is kerosene. Refractive index of kerosene is equal to 1.44. It is given. Then for similarly refractive index of diamond. Refractive index of diamond is given as 2.42. See, refractive index of some of the material. That means here what is refractive index of air is that is the speed of light in vacuum divided by speed of light in air gives refractive index of air. Refractive index of water gives speed of light in vacuum divided by speed of light in water. Then kerosene this way. This refractive index depends on, that means optical density. Refractive index also depends on, refractive index depends on optical density of the medium. Refractive index depends on optical density of the medium. When optical density increases, refractive index also increase. That means optical density means how the velocity of the medium, that is velocity of light in the medium affects. Here you see optical density related to refractive index. As the optical density increases, refractive index also increase. Here you see examples, kerosene and also water. Refractive index of water is 1.33 and refractive index of kerosene is 1.44. Among these, that means among these mass density of water is more. Mass density when we consider mass density of water is more than that of kerosene. But optical density or refractive index does not depends on what is mass density. That means mass density of water is more, but optical density is less, or refractive index is less. Here, see, mass density of kerosene is small, but optical density is small. That means optical density more for kerosene, but its mass density is less. This also you want to observe in your observation when you going through the table. Okay, now see some questions given in our discussions. Once again, I am going to say refractive index means what is actually when light travels from one medium, for example air, to another transparent medium, for example glass, it deviates. That deviation depends on refractive index. That depends on refractive index equal to speed of light in first medium to second medium, refractive index with respect to second or second to first. From this we got the refractive index of different media, and also from this we can understand one things, that is optical density, not mass density. Optical density related to speed, but mass density is the mass by volume. That optical density depends on mass density always. For example, kerosene optical density is more, but mass density is less than that of water. Now, some question given to you, answer. See the first one, a ray of light traveling in air enters obliquely into water. Does light ray bend towards the normal or away from the normal? Why? The first question given is a light ray entering from, this is air, this is, that is second medium is water. This is the two figure, that means from here, this will bend towards normal as like or this way, normal, this is the actual path, or bend away from the normal. This is the question. See, air and water, when we consider, water is the optically denser. Water is the optically denser than air. So the light ray, when light enters from optically rarer to a denser medium, optically rarer to a denser medium, it bends towards the normal. So this figure is the correct one. That means the light ray bend towards the normal. Okay. And second question given for you. Light enters from air to glass having a refractive index of 1.50. What is the speed of light in glass? The speed of light in vacuum is 3 into 10 raised to 8 meter per second. See, light enters from where to where? Light enters from air to glass of refractive index 1.50. That means the refractive index of glass to air is 1.50. That is speed, refractive index we know, second medium glass first air is equal to V1, that means velocity V1 by V2. So N21, it is given as 1.5 is equal to 3 into 10 raised to 8 speed of light. This is the speed of light in glass V2. So V2 is equal to 3 into 10 raised to 8 divided by, see, we want find V2. So we change this V2 to this side and this 1.5 to this side. So V2 is equal to 3 into 10 to the power 8. 3 into 10 to the power 8 divided by 1.5. That is equal to 2 into 10 raised to 8 meter per second. This is the answer for second question. V2 is equal to 2 into 10 to the power 8 meter per second is the speed of light in the given glass. And third question given is find from the table the medium having highest optical density and also find the medium with the lowest optical density. Highest optical density we know diamond with a 2.42 and the lowest optical density air with a 1.003. So answer diamond with the highest optical density and air with the lowest optical density. This is the answer for that question. And now fourth one. You are given kerosene, turpentine and water. In which of these does the light travels fastest? Use the information given kerosene, turpentine and water. These are the three things given. See, from the table we can get refractive index of kerosene is given as 1.44 and turpentine is 1.47 and then water 1.33. Among these refractive index is water is 1.33. When the refractive index increases, speed of light decreases. When the refractive index increases, speed of light decreases. So water is with the maximum speed of light among these three. Through water, light travels with the maximum speed. That is 1.33. Then one more question is given. The refractive index of diamond is 2.42. What is the meaning of this statement? That means the refractive index of diamond is given as 2.42. Here given refractive index of diamond is 2.42. What does it mean? See, we know refractive index is equal to speed of light, that is 3 into 10 raised to 8 divided by speed of light in diamond, let it be V. Here it is, this n is given as 2.42 is equal to 3 into 10 raised to 8 by V, or V is equal to how much? 3 into 10 raised to 8, 10 to the power 8 divided by 2.42. Here the meaning is that speed of light in diamond is 2.42 times smaller than as that of in vacuum. Or we can also represent V into 2.42. That means speed of light in vacuum is 2.42 times as that of speed of light in diamond. This is the meaning we getting from this. That means the speed of light in diamond is smaller than that of given in vacuum or air. Okay. Today we discussed the points refraction and examples and two laws of refraction and that refractive index, optical density and the questions given in our text and its answers also. With this we can wind up this class. Okay.